What is up, everybody? Welcome back to another episode of Chat HVAC. How's it going, everybody? Welcome back to another episode of Chat HVAC. My name is Scott Jackson, and I'm the senior technician here at Comfort Solutions Heating and Cooling. And if you're watching on YouTube or Spotify or anything like that, you can obviously tell right from the jump, this is a little bit of a different episode. As I've said before, I'm the senior technician here at Comfort Solutions. And today, I just didn't have the time afforded to me to sit in our normal studio space and record an episode. So you are coming along in the truck with me this morning. It is a brisk 15-degree morning this morning. And what I was going to talk about today was kind of just holiday related and, how to keep your home warm with a bunch of people in your house and not spiking your energy bills or anything like that. But I decided to change course a little bit. And the reason why is because this is a service call that I've been getting a lot over the last few days, and it relates to heat pumps. So if you live in a cold climate, or even a semi-warm climate, like further down south, whether it's like Tennessee or Georgia or something like that, you're probably familiar with heat pumps. And they're really pretty cool. It's like an air conditioner with a reverse gear, so to speak, so it can reverse the flow of refrigerant and produce heating instead of cooling. But they don't always perform the best in cold climate conditions. Now, cold climate, I'm defining as, just so we know our terms and we can define our terms here, I'm defining cold climate as any climate that regularly gets to single digits. So that would be up here in Ohio, anything north of here for sure, and even a little bit further south of where I'm at in Ohio. But up here anyways, heat pumps have the tendency to perform less than stellar, so to speak, in these cold climate conditions. And the reason why is what it's doing is I think it's important to discuss how an air conditioner works before we jump into why a heat pump might struggle in these colder temperatures and why we have things like electric heat or dual fuel systems or things like that. But what an air conditioner does, just on a very fundamental level, is an air conditioner is absorbing the heat from inside the house, transferring that heat to the refrigerant that's inside the indoor coil and taking it outside. So the indoor coil gets really hot. Your hot air from your house blows across that coil. It displaces that cooling that is being produced there into the house, so the coil breeze and things like that. It's constantly blowing the warm air from the house over the coil, so it doesn't breeze. But what's happening is that coil is absorbing the heat from the house and is sending it to the outdoor unit and disposing of it out there. That's, again, on a very fundamental, basic level, that's what an air conditioner does. What a heat pump does is the exact same thing in reverse. So instead of taking the heat from inside and taking it outside, it takes the heat that's in the outdoor air and puts it inside. Now, this works really well, especially in temperatures between, say, 55 degrees and 35 degrees. But when you get below that 35, 30 degree, 25 degree mark, depending on the efficiency of your heat pump, that's when a heat pump can tend to struggle. Now, why do heat pumps have issues in the wintertime? Well, obviously, as it gets colder outside, there's less and less heat able to be taken from the outdoor air and put into the inside of the house. A heat pump can run below 20 degrees outside. It can run all the way down to 0 degrees or even lower than that. It'll run and come on, but the amount of heating that's being produced is not nearly enough to satisfy the load that's on the house because of the extremely cold temperatures, especially when you're down in single digits. So something that we often see, especially in these northern climates, is some sort of secondary heat source, whether that is electric heat strips that's in the air handler inside, whether that's a gas furnace or a propane furnace or an oil furnace. We see a lot of those up here. One of those things is going to provide a secondary heat source to be able to supplement the heat pump in the event that the heat pump is not able to produce enough heat in the wintertime to keep the house at an desirable temperature. Now, I mentioned at the top of the episode that this is a call that I've been getting a lot over the last few days. Really, not any one particular problem with heat pumps, just kind of heat pumps across the board. And especially people who have gone from straight air conditioning systems and they've adopted heat pump systems, whether they didn't have heat in their house before, which again, believe it or not, is unbelievably common, or they just wanted to kind of move from the air conditioner to a dual fuel type system to be a little bit more environmentally friendly, energy efficient, those kinds of things. But one thing that I find, especially with new people to heat pumps, is the air coming out of the registers doesn't exactly feel hot. And there's a reason for that, of course. You're not burning any fuel. So the heat from a heat pump compared to the heat from a gas furnace or something like that is very, very different from each other. So your average gas furnace, you could expect to see supply air temperature of anywhere from 120 to 140 degrees on the high end. Your older furnaces will have higher supply air temperatures. I think they have like a maximum of 200 degrees. But you get the point. The point is, with gas furnaces, oil furnaces, those kinds of things, the air coming out of the registers is going to be much, much hotter. It's a hot heat. And those of you who have heat pumps, you can relate to this term that I'm about to say, where a heat pump produces a cool heat. So the supply air temperature that you can expect from a heat pump system without the electric heat, without any sort of secondary heat running, is kind of in that 90 to 105 degree range, depending on the outdoor temperature. And now, as that gets below, for your average heat pump, as that gets below 35 degrees, that temperature that it's producing is going to get less and less and less. And obviously, that's why we see it struggle and why we need a secondary heat source in the northern climates. But I just wanted to real quick today give you guys a few things that you can look for if you're having any issues with your heat pump, if you're wanting to know what's normal, what's not. Maybe you just got a new one and you're not really familiar with how it works. Or maybe you just got a heat pump for the first time and you're one of those people that I mentioned earlier who had an air conditioner but went to a heat pump, whether that was for the tax credit incentives or manufacturer rebate incentives, or you just wanted to be a little bit more environmentally friendly with your heating source. I just wanted to address a couple of the primary concerns, primary questions, and maybe some questions that you might be having right now as we're getting into the colder temperatures. And you just want to know kind of what's normal, what's not normal, what to expect with your heat pump, and maybe potentially even solve your own problem to a certain degree. So the biggest call that I get personally about heat pumps is my heat pump is making a really loud noise outside. This can be caused by a couple things. Most notably, this can be caused by the heat pump going into what's called a defrost cycle. So because the heat pump is running while it's below freezing outside, and it doesn't even have to be below freezing for it to initiate a defrost cycle, the outdoor coil, again, we're looking at an air conditioner, so we're switching places. The indoor coil in the air conditioning mode gets cold, the outdoor coil gets hot. With a heat pump system in the heating mode, that's reversed. So the indoor coil gets hot, the outdoor coil gets cold, and that outdoor coil consistently drops below freezing. And as you all know, if there's any moisture or anything at a below freezing temperature, it's going to freeze. It's going to make ice. So the heat pump is known to make ice, especially in these colder weather temperatures. And what it does is it goes into a defrost cycle, which to just very loosely explain what that is, it switches the flow of refrigerant back and it causes the outdoor coil to get really hot, thaw itself out, and then switches it back to the heating mode direction and continues to operate like normal. But this defrost cycle tends to be noisy, tends to be loud, tends to be a little obnoxious, especially with your lower efficiency heat pumps or single stage heat pumps, things like that. But really any defrost cycle is kind of obnoxious. So that's really the primary cause for the noise complaints with heat pumps is your defrost cycle. Now, another thing that I have seen, I actually just ran into this yesterday, is ice buildup on top of the fan. So this particular customer had a gutter that was dripping directly onto the top of the heat pump. So there was a bunch of ice buildup on the top of the heat pump where the fan is at. And because it was so cold and there was so much water, like the day before, it was a little bit warmer. It melted a lot of ice that was on the gutter. And then all that water got down onto the heat pump. It froze overnight and it caused the fan to freeze in place. But before that, it was kind of like chopping ice that it was running into on the body of the unit from the water dripping down the day before. So sometimes that can be the case. Maybe your heat pump has built up some ice and the fan blade is hitting that. It's a little bit less common, but I do see that quite frequently. So that would be the first primary concern that I get from homeowners like you about heat pumps is why is it making such a loud noise? The second concern that I get a lot from homeowners as it relates to heat pump systems in particular is why is my electric bill so high in the wintertime? Now, this could be twofold. One is you could have a legitimate problem in which you could be low on refrigerant and your electric heat is coming on for a lot longer and a lot more frequently than it needs to. And I'm only mentioning electric heat because that's the typical application for heat pump systems that I see up here as the backup source. So your electric heat is essentially a glorified space heater. We all know how expensive it is to run space heaters in the house and how expensive it is to run like electric heating elements, things like that. This is the exact same thing. It's a giant toaster that's inside of your air handler. And the air blows across it, and that's where you get your heating from. So whenever the heat pump isn't able to keep up, the electric heat will come in and supplement. And if in case of really cold temperatures, that heat pump isn't really able to produce anything, and sometimes you're running on straight emergency heat or auxiliary heat. You'll hear those two terms as it relates to heat pumps. But yeah, that's typically the reason. The biggest reason why is you might have an issue if your bills are higher than they normally are. Like something has changed, and of course, the cost of utility hasn't changed. You'll want to look at your usage as opposed to just the flat cost. If your usage is going up and it's a lot more than it normally is, then yeah, that could be indicative of a problem. That would be a good time to call out a professional. If you're here in the Cincinnati area of Ohio, you can give Comfort Solutions a call. All of our contact information, website information, all that's in the description of this video today. But that would be the biggest reason. Another reason is if you've never had a heat pump before and you kind of just adopted one, maybe you're just not used to how often the electric heat comes on, things like that. But by and large, your bills are going to be a little bit higher in the wintertime with a heat pump system as opposed to the summertime because of the presence of electric stripping. But in summary for that point, the biggest, most common reason why customers call in with complaints of higher utility bills, other than the price of electric going up, is the fact that there is a refrigerant problem or some other mechanical problem with the outdoor unit. The heat pump's not able to work, so the emergency heat kicks in. So that's the straight electric strip heat, and that's incredibly expensive to operate. So again, to summarize here, point number one, why is my heat pump operating so loud? Typically the defrost cycle, or it could be the fan blade could be hitting some ice outside. But if it's anything that's out of the norm, you want to give us a call. You'll be able to establish kind of what's normal for your heat pump, the longer you're with it, or the longer you live in the home that has the heat pump, things like that. You'll be able to kind of figure out if something isn't normal, so to speak. And then point number two is why is my energy bill so high? And it could be indicative of a problem. Again, look at the usage on your utility bill, not so much the flat cost, because cost of utilities tend to fluctuate over time. And also, it could be indicative of a refrigerant problem in the system, causing the electric heat to come on a lot more frequently. The third point I want to discuss today, and kind of the final point that I'll leave you with, is the biggest question, one of the biggest questions that I get from homeowners as it relates to their heat pump in the wintertime is, why does the air that is coming out of my vents feel cold? Now, this could very obviously be a problem, especially if it's warm one day but cold the next, or warm 1 hour and then cold the next hour. That could obviously be a problem, and you use your discretion as to what's normal. But this primarily applies to people who maybe you just moved into a house that has a heat pump. You've never had a heat pump before. Maybe you just adopted a heat pump, like I alluded to earlier, where you had an air conditioner before, but then you decided to go to a heat pump, whether it was for financial incentives or whether you were just wanting to have your heating be a little bit more environmentally friendly. Whatever the case may be, a heat pump does not produce the same intensity of heat that a gas furnace or an oil furnace or something like that will produce. It doesn't even produce as hot of heat as your electric strip heat does. And the reason for this is, again, it's operating essentially the same way an air conditioner does, just in reverse. And typically, in the air conditioning mode, We like to see the difference between the temperature of the air coming out of the registers and the temperature in the house. We like that to be anywhere from 18 to 25 degrees, depending on the outdoor temperature. The heating mode is the exact same. So we're looking for an 18 to 25 degree difference in the air temperature coming out of the vents compared to the temperature that's in the house. And that kind of gives us a good idea as to what's normal, as to what is a proper operation of a heat pump, so to speak. So the primary reason why, again, this mainly applies to people who are new to heat pumps and things like that. The primary reason for air temperatures being cool is sometimes it's getting used to how a heat pump operates. And especially as it gets colder outside, it won't feel super hot to the touch coming out of your vents. It's nothing to have, say, 88-degree air or 90-degree air coming out of your vents. It might technically be enough to heat your house and produce the amount of BTUs that you need to keep the house at the proper temperature, things like that. But it doesn't feel hot. So when you go put your hand in front of the register, it doesn't have that nice, warm, cozy feeling. And that's just the nature of heat pumps. Heat pump technology has come a really long way over the last few years. I know we're a Lennox dealer. We have been for a long time. I've mentioned their products before, but Lennox has done some really good work with their Signature Series heat pump. It's one of the highest efficiency heat pumps available on the market. It does an incredible job at operating at low temperatures. I believe it's able to output 100% of its heating capacity down to 5 degrees outside. It does a really, really, really good job. And I'm thinking about reaching out to Lennox and trying to have somebody from the manufacturer come on the podcast and talk about their products and what it might mean for homeowners and what they might be interested in, things like that. If that's something that you might be interested in, leave a comment below. Let me know. And I'd love to arrange that and maybe make it a little bit more of an interesting episode than you all just looking at me talking to you for 20 minutes. But heat pumps they're really cool pieces of equipment. They have a good place and they do a good job at what they're supposed to do. It's just creating accurate expectations with air temperature, with heating capacity at certain outdoor temperatures, things like that. A couple years ago, we had a really, really intense spurt of cold in the winter where it was, well into the negatives. I think we were -10, -15 degrees actual temperature up here for about a week. And anybody who had a heat pump called in and thought it was broken. But it wasn't broken. It's not able to operate that cold. And their electric heat just wasn't able to maintain, say 72 degrees in the house at that extremely cold outdoor temperature of -10, -15 degrees. Again, curbing your expectations to be a little bit more accurate with what heat pumps can produce, those kinds of things. If you want any more information on heat pumps, I know this is a really quick overview, kind of the basic questions that I get from customers a lot, homeowners just like you. But if you want any more information on heat pumps, let me know. I can do some more episodes on heat pumps and we can talk about heat pumps and maybe ask me your specific questions. It'd be really cool to do like Q&A style. If any of that stuff interests you, drop it in the comments. I'd love to engage with you down there. We try to engage with all of our commenters and get back to you in the comment section. So all that being said, this is going to conclude today's episode of Chat HVAC about heat pumps and heat pump technology and heat pump expectations. If you have any questions, concerns, comments, let us know. Our website is in the description and we'd love to hear from you. And of course, if you're in the Cincinnati area of Ohio and you need your heating system looked at, whether it's a heat pump, whether it's a gas furnace, whether it's a boiler, whether it's a geothermal system, please give us a call. We'd be more than happy to come out, evaluate the system for you, and get you up and running in the proper way. But all that being said, my name is Scott Jackson. This is Chat HVAC, and we'll see you all next week.